Okay, so we can use this equation to calculate the density of the gas. And we also, if we know the density of the gas, we also can calculate the molar mass of the gas. So in this equation, when we know the gas, what the gas is, so of course we can know its molar mass, right? So we can use its molar mass to calculate the density. If we don't know the molar mass, we can use its density to calculate the molar mass. Because sometimes we can do experiment to measure the density of the gas. After we get the density of the gas, we can calculate its molar mass. Okay? So here's the question. So a 2.1 liter vessel contains 4.65 grams of gas at one atom at 27 degrees. So what's the molar mass of the gas? So in this question, we know the volume. We also know the mass, pressure, and the temperature. We should use these conditions to calculate the molar mass. So in this equation, we can use this equation to calculate the molar mass. And then it's D, what's D? D is the density, right?
Yeah.
So what's the density? Yeah, mass times the volume. Okay, how to? Nice.
Sequenzi.
Two point one liter.
I thought it was 8. Don't matter.
Okay, yeah. And then how to calculate the molar mass?
That's to be Kelvin, right?
Yes.
Yeah, so.
No. Yes.
Both of them. Yes, sir.
Okay, so the only pressure is now the SI unit. SI unit, yes.
That's too good.
M. Just M.
Yeah.
What's M? What's M? That's just M.
Yes, scream more. Okay. Yeah, good. This time you were correct.
I was saying to these guys, you know?
So basically, yeah, we can use this mass and divide by the volume to get its density, and then we can use the R constant and the temperature should always be the Kelvin, and the pressure is 1 atm, and then we can get the molar mass. So the unit of molar mass is grain per mole or mole. Okay.
Yes, sir.
Doesn't work. Okay, just here. So basically, here first we get the density, okay, and then put this inside. So finally we get the molar mass. Okay. So basically, for the molar mass, we can also use the other way. We can determine what the gas is. What the gas is. Okay. So here to introduce how to use the gas stoichiometry to do the calculations. Yeah. Okay. For example, this question. So what is the volume of CO2 produced at 37 degrees at 1 atom when 5.6 grams of glucose are used in the reaction? So this is the reaction, okay? And in this reaction, we know the temperature, okay? We also know the pressure. We know the mass of the reactant. Now we need to calculate the volume of product. So basically, when we know the mass of the reactant, this guy, we can calculate its moles, right? Amount, mole, the mole number. So when we know the mole number of the reactant, we can get the mole number of the product, right? Because 1 mole reactant, this reactant, will produce 6 mole of this product. So when we know the mole of this guy, we can get the mole of this guy. After we know the mole of this guy, this means we know the N number, right? We know the N number, and then we can use the gas equation to calculate the volume of this guy. Okay, so So how to get the answer?
Monitor, everyone there. Everyone there.
What?
Answer the question.
Which question?
You are on the phone.
So now question. Who want to try?
Monitor.
Monitor.
Wendy.
Yeah, oh, okay. So here we can say, get the mass of the reactant, right? This is the molar mass of the reactant. So from the mass divided by molar mass, so what does this mean?
That's the number of moles.
Yes, number of moles of this product, right?
Good.
After get this number, and then we can get this number, right? After we get this number, how to calculate the volume? Nobody want to try? Hey, monitor, you want to try?
Okay.
Yeah.
Good boy. Very good. You want to go some?
Good. Yes. So this is more of the product. Yes.
What's the answer?
Rejection. What are you multiplying?
This.
5.6 times what? We start with dividing, right? 5.6 divided by 182.
I saw that you will answer the question.
0.186.
You are
0.1866666.
okay. It's more. Yes.
It's sad.
Oh, so smart.
Yeah, temperature.
What's
30.
37 plus whatever.
73 is 300. 273. Hey, no, it's 310.
What?
I'm not going to sure.
Yeah, not like
It is 4.762.
Okay, good. Yeah, thank you.
Can you be so smart?
So basically we can say for the calculations of the gas, we always using this equation PV equal nRT, right? So if we need to calculate the volume, so we just use the volume equal nRT divided by pressure. So in this equation, we know the pressure, we know the temperature, the R we also know. So we just need to figure out the N number, the amount of the gas. So the N number, but we know the mass of the reactant. So from the mass of reactant, we can get the mole of reactant. And from the reaction, we know 1 mole will produce 6 mole. So just using the mole number of the reactant times 6, so equal to the mole of the gas. After we know the mole number of the gas, and then finally we can get the volume of the gas. Okay? So any question for this? So from here, yeah, we can see the mole number of the product should be obtained by the mole of the reactant. Okay? Okay. Oh. I don't know why it doesn't work.
I think it's low battery.
Anyway, we will finish soon, I think. Okay, so it's time 6. It means the mole number of the gas. And the volume is this. So you can get. Okay. So basically, you don't have to remember the number of the R constant, right? It's too complicated. You just should always remember the temperature should be Kelvin, pressure using atom, okay, and the amount of gas should be used mole, and the volume should be used liter, okay, and then you can use this constant to do the calculation. Okay. Okay, this picture to show us how to calculate the gas from the experiment. So we know this reaction, when hit this solid, it will release the oxygen gas. Oxygen gas. So like this, we will hit here, and it will produce the oxygen gas. And in this gas, at first it filled the water, okay, and then when the oxygen gas come to inside, so because it has some pressure, and it will move the water out. So and then the glass will be filled by oxygen. So I'm not sure whether you did this experiment before. So I know in China, the high school students, they should do this experiment. High school students. Yeah.
It's like
It's not very complicated. It's simple. This is a very simple experiment in chemistry. Yes, there are many very complicated experiments. But this one is very simple.
In Zambia.
Okay, so this curve to show the weight of the water and the temperature. So from here we can see when the temperature increase, when the temperature increase, the pressure will also increase. And when the temperature is 100 degrees, so the pressure is one atom. And we know at this temperature, is also boil point of water, because at this point, at this temperature, the pressure is equal to the environment, right? Equal to the air. So it will boil. Okay, so this is the last question. So we know this picture to show the diving in the sea. So basically it will really will breathe out some gas, right? So when the gas in the sea, now the question is, when the gas raise, the bubble, the volume of the bubble increase or decrease? It breathes out the gas, like the air, like, and the oxygen or carbon dioxide. And for the gas, the volume when it release, when it go up, the volume of the gas will increase or decrease. Decrease. Why decrease? The volume of the bubble decrease. You think it's decrease, right? Why?
Maybe because of the pressure of the water. It's like,
Yeah, we know this, right? So the pressure the pressure here and here, where is high? Here is high, right? The first is high, right? And then the pressure will decrease, right? So the volume will decrease or increase?
Increase.
Yes, increase, not decrease, okay? So the bubble will increase, just because, you know, N, R, T are constant in this case. But the pressure, when the bubble go up, the pressure decrease, right?
Yes.
And the volume will increase. So because the bubble become bigger and bigger, right? Okay. Okay. One more. So that's all for today. 谢谢老师。